Okay, you've got a couple of quiz problems here. What exponential form of the function y equals b to the x passes through this point? Well, I'll say if the graph passes through 2, 5, where y equals b to the x, then 5 equals 2 to the x. Sorry, b to the second. Okay, we're replacing y by a value of y, replacing x by a value of x. We know that a graph passes through a point, we can always write the equation. Okay. This equation can be solved for b. Now, right now, I'm going to just okay. I want you to see that whole thing. I left myself room to come back and solve for b. Okay. Now, I'm just deciding how I want to state this. If y equals a times b to the x, two, 5, and 8, 12 are on the graph, then we can again substitute 5, 2. That's the same point we just substituted up here, but this is a different function. So we can substitute I'm going to write out some more words. We can substitute x equals 2, y equals 5 into this form and get one equation. Then x equals 8, y equals 12. Get another. Now there's a reason we need to get two equations. It's because we have two parameters here, a and b. X and y are your variables, okay? And then a and b are numbers that we've got to find so that we know what the function is. So if y equals ab to the x, we have these 2 points. Substitute x equals 2, y equals 5. We get 5 equals ab squared. And 12 equals ab to the 8th power. So now we get two equations. I'll leave this here. Okay, y equals mx plus b, and these 2 points are on the graph. Then we can substitute each point into the equation, and we'll have 2 equations. Since we want to find m and b, that's going to be very helpful, okay? So what I want you to do is go ahead and substitute and see what 2 equations you get. I'm going to write down another one. Go ahead and see if you can write down what those 2 equations are. Let's just do this. Get that one, see if you just write out, all you gotta do is write it out, talk about solving them. After we're sure we can write them out. Okay, yes, everybody has found out because everybody did this very well. Once you get the hang of this, it's pretty easy to write the equations. Now, solving the equations is a different thing. So we got to see how to solve some of these equations, okay? So this equation, you're going to get the 0.6 negative 4, you're going to get 6 equals m times negative 4 plus, whoops, you're going to get negative 4 equals m times 6 plus b, okay? And from the point to 12, y is 12. So we're going to substitute that for 12. We get 12 equals m multiplied by 2 plus b. Okay? Does that make sense? Is that what you got? Yeah. So that's what you got. You wrote down exactly what I did. Okay. So you've got the equation. Everybody's got the equation. Okay, on this one, what are we going to do? Now I wrote the point and I wrote an arrow to the equation just so I can match up the point with the equation. Oh, you know what? I see you don't have exactly what I have because I did something wrong there. Okay, this point was negative 4, 6. So the way I wrote it down first was correct. I was just careless when I wrote the point down. Equals then 6 equals m times -4. Sorry, is my error. No wonder everybody's looking at me like I was crazy. Yeah, you know, I'm not crazy, but that's certainly careless there. Okay. Y equals x to the p, and 3,8 is on the graph. Well, the point 3,8 gives us 8 equals x to the third. Sorry, 8 equals x to the p. Yep. Maybe I better learn to do this. Yeah. It's y equals x to the p. Y is 8, there's 8. X is 3, we put 3 in there, we get 3 to the p. And now, these two equations we can easily solve. We learned to do that in chapter 2. Might have to review that a little bit, but we can solve these equations and we get values of m and b. There are a couple of ways we can do that. Okay. This equation, which is only one equation, it's only one variable p, we can't solve this one right now. We have to use logs. Okay. But here I'll say, we can solve this. But by the time we get to the end of this chapter, you'll know how to solve that. And it's pretty easy. But there are a couple of things we have to do first. Okay, now we have y equals ax squared plus bx plus c, and we have these points. Okay. X equals 2, y equals -4. So point 2, -4 gives us this. Point -3, 9 tells us that 9 equals a times -3 squared plus b times -3 plus c. And then I didn't really leave myself quite enough room, but I'm going to do it anyway. 0.65 tells us that y is 5. So y is here, so 5 is going to equal a times 6 squared plus b times 6 plus c. Now we have 3 equations. How many unknowns in these 3 equations? What are the unknowns? Well, they're a, b, and c. So we got to find the values of a, b, and c. This is something we're not going to do right now. You do know how to use elimination from chapter 2, but only with 2 equations. When we've got 3, it's not much harder, but there are more steps. So at the end of the term, we're going to learn to solve 3 equations and 3 unknowns. And we're also going to learn to write this down as a matrix equation and use a matrix to do the solution. So that's coming up, something to look forward to. Now we got y equals ax to the p with the points 2, 3, and 5, 8. Well, that means y is 3. Three equals a times 2 to the p. 0.58 gives us 8 equals a times 5 to the p. Can't believe that's what I saw in every paper. Okay, so doing real well with getting the equations. Now, how do you solve the equations? So let's go back to this equation. 5 equals b squared, solve for b. It might be easier if you write the variable you're trying to solve for on the left. So we rewrite it as b squared equals 5, because it looks better that way. In the solution, anything squared equals a number is b equals plus or minus the square root of 5. Now let's check that. If I square the square root of 5, what do I get? Well, I get 5. That's what the square root means. Square root of 5 is a number I square to get 5. I'll say b is approximately 2.23. And if you square 2.23, you're going to find out it comes out very close to 5. Maybe it's like 4.97 or 4.98 or 5.01 or 5.02, but I'm going to give you a number that's still real close to 5. And if you used your calculator, you could get a lot more decimal places out here. And if you got a lot more decimal places, when you square it, you get something a lot closer to 5. Okay. Got clear on this thing. Can't see if I'm recording or not. Okay. So those are your solutions. B equals the square root of 5, or B equals negative square root of 5. Now, the other thing we do is we go back to our original equation, and as it turns out, you can't have a negative value of B. Even though the equation gives us the negative value of B as one of the solutions, it doesn't work up here, okay? B has to be greater than 0. So we reject this because B has to be greater than 0. Not that this isn't a solution to this equation, it's just that you got to make sure, if you got more than one solution to the equation, you got to make sure that every one of those solutions makes sense. All right. Now down here, we got the equation for the system. 5 equals AB squared and 12 equals AB to the 8th, right? So let's just kind of rewrite that. The point, the 2, 5. And a 12. We get 2 equations. Now let's call this one, okay. Solve this, we solve the first equation for A. Something must be wrong. Okay, you're telling me that I'm not being careful again. it's b to the x, and b is a parameter, and x is value of x. So sorry, it's b squared and b to the eighth. Okay. I would have figured that out when I started solving it, but so can you solve the first equation for A? Well, this is where some people have a little bit of trouble, so let me do that. Okay, we have five equals AB squared. Let's write that as AB squared equals 5. And B is a variable that we're trying to solve for. So kind of underline B. We want to get B all by itself over here. What operation could we do? We could divide both sides by A. Get AB squared over A equals 5 over A. And then, of course, since A divided by A is 1, we get B squared equals 5 over A. So B is the square root of 5 over A. Can you plug this into the second equation? In other words, instead of B in the second equation, write 5 over A, the square root of 5 over A. Second equation has eighth power, not the second power. Okay, so make sure you get that power right, but that's right. Okay, well, we plug this into the second equation, which is 12 equals AB to the eighth. So we get 12 equals 8 times the square root of 5 over A raised to the eighth power. Now that's a little bit complicated because of the exponents, but it's easy to do. This is the 1/2 power of 5 over A. So this ends up being the 4th power of 5 over A. And we can easily solve that. I'm going to show you an easier way to do this. So I'll just write this down, but I don't want to strain your algebra to that point. Okay, but you understand that this equation here has only A as a variable, so we could solve it for A. Easier. Divide one side of the equation by the other. This means, of course, that's an abbreviation for divide the left side by the left side, divide the right side by the right side. Okay? And I'm going to choose to divide the second equation by the first. And I'll explain why I made that choice in a minute. So we're going to get 12 over 5 equals AB to the 8th over AB squared. Now, do we understand that? Left-hand side of the second equation is 12, right-hand side is 5. So we divide left-hand side of the second by the left-hand side of the first. Then we divide the right-hand side of the second by the right-hand side of the first. And what happens when we do that? Let's just write out. This could be written as A over A times B to the 8th over B squared. Well, what's A divided by A? 1. What's B to the 8th divided by B to B squared? Well, we use a rule for exponents. B to the 8th divided by B squared is B to the 8 minus 2. 12/5 equals B to the 6th. Now I'm going to rewrite it with B on the left, just because it looks a little better that way, and you're going to be more likely to recognize it if the variable you're solving for is on the left. There's no reason it couldn't be on the right. But I think it'll jog your memory better here. So what we have to do at this point, we want to get B. So we raise B to the 6th to the 1/6 power. Because you know, when we do an exponent of an exponent, we multiply the exponents. And then we have to do that on the right side. That gives us B to the 6th times 1/6 equals, well, I'm just going to leave 12 over 5 to the 1/6. That's something you're going to have to plug into your calculator. So B equals 12/5 to the 1/6 power. Now let's see, what would I take 6 powers of to get 2.4? You get 1.1, look at 1.4. It could be 1.2, get 1.44. About 2. 2 is going to be too much. I'm gonna guess that this may be around 1.17. Thinking that may be a little bit too high, maybe closer to 1.15. Okay. Now, first, do we understand these steps? We have b to the sixth equals 12/5, and we want b. What can we do to b to the sixth to get b? We can raise it to the 1/6 power. And then use the rule for an exponent of an exponent. See, that's b to the sixth times 1/6, which is, of course, b to the 1. I'll write the 1 there because 6 times 1/6 is 1. And we get b approximately 1.17. And, you know, I'm kind of wrong about that. I think it's about 1.23. My brain is not functioning today. Okay, can you punch that into your calculator and see what 12/5 to the 1/6 is? Not so much to check my mental arithmetic, but to make sure you're doing this right. Okay, my original estimate was 1.17. I lost my mind and wrote 2.3, but I was thinking wrong. But I brought the 1.17 down to 1.15, and actually it's 1.157 something. Okay, so it's actually close to 1.16. Now we plug 1.16 in for B into either equation. I'm going to make myself a little space here. I want to keep it on the same board. And I'm going to plug that into the first equation. We get 5 equals A multiplied by 1.16 squared. Well, 1.16 squared is about 1.33. So we can say, okay, 5 equals A times about 1.13. That's an approximation. Then we want to solve for A, and we're going to get A approximately equal to 5. It's not 1.13, it's 1.33 over 1.33. And that would be 3/4 of 5, which is can figure out what to write at 3.75. So now we know what our function is. Our function is
You need me to drop all?
was approximately 3.75 times one point one six to the x power. Now to check this, you plug in x equals 2 and see if this doesn't give you 5 or close to it. Then plug in x equals 8 and see if this doesn't give you something very close to 12. That halfway makes sense? So we could follow a common procedure and solve this first equation for one of the variables. I chose to solve it for a. And when we got down here, we got kind of a messy expression that we didn't want to take time to explain, okay? You can avoid that if you divide one side by the other. If you divide one side by the other, then a is going to divide out. Because you have a divided by a. Now I wrote that out in a couple of steps to show you why it is. But anytime you have an a in the numerator and an a in the denominator as a factor, a multiplied by the rest of the numerator, a multiplied by the rest of the denominator, you can do that. So you can verify that a over a times b to the eighth over b squared does equal a times b to the eighth, which it should, over a times b squared, which is what it should. Okay, so this is why you can do this. A divided by a is 1, and of course then b to the 8 over b to the seconds, b to the 8 minus 2, and you end up with b to this power. Once you've done a few of these, you can recognize, well, all I got to do is divide one of these equations by the other. I'm going to end up with b to some power equals some number, and then I can just take the reciprocal power and get that number. I have to use a calculator, most cases. You take that number and you plug it into either equation, and you're going to get a number for a. Then you replace a here with the number you got for a. There it is, a is 3.75. And replace the other number, b, by what you got for b, which is approximately 1.16. Now, we know it's closer to 1.157. I was just lucky to get within a hundredth of it by estimating, and you don't know. Can't be expected to be able to do that. Do that in the calculator. So anyhow, we replace b with a 1.16, and we've got our function. And now the graph of that function has to go through these 2 points. So could you quickly sketch a graph of an exponential function that goes through these 2 points? Just start by, okay, I'm getting a lot of blank looks there, but you start by drawing those 2 points on a graph. Then you draw what looks like an exponential curve. Okay. So if we draw this curve, kind of close this exercise out. Our points were picture 2, 5, and 8, 12. Okay, so here's the graph. Put x equals 8 out about here. 4 would be about here, 2 would be about here. So we'll say here's x equals 2. And we have y equals 12. And y equals 5. 5 is a little less than half of 12, so it'll be a little less than, or a little more than halfway to the lower edge here. So we have this, we have a couple of points. And then we sketch an exponential curve that goes through these points. Has to start at the y-axis, has to have the shape of an exponential curve. And it's kind of hard to do that with just 2 points. So I'm just going to kind of do something. Oh, trying to turn it there, I didn't make it. Okay, so I kind of missed it by a little bit. But you get the idea. There's your exponential curve. And this model is y equals ab to the x, which is approximately 3.75 times 1.16 to the x. The y-intercept occurs when x equals 0, so y would be 3.75 times 1.16 to the 0. And 1.16 to the 0 is just 3.75. So this point ought to be 0, 3.75. This line ought to be y equals 3.75. And that kind of makes sense. You look at the numbers. Okay. Now we're not going to go back and look at the solutions to the other equations. I threw those out just so people would get comfortable with plugging the coordinates of points into the form of a function. Our main focus was going to be to get the graph of this function. Given 2 points, get the graph of the exponential function.